If you are building a backend with JavaScript, chances are you'll be using Express.js. It's the go-to framework for creating powerful APIs and web servers. But here's the thing. Most tutorials on Express and Node.js are outdated. They rarely show you how to use TypeScript, which is now essential for writing clean, scalable, and maintainable code. In this video, I'll show you how to build a modern Express server with TypeScript, including how to serve static files, render dynamic templates, create REST API, use middleware, and handle errors the right way. And if at any point the code feels a bit overwhelming, feel free to check out complete guides for Node.js and JavaScript that I linked in the description below. They're great not only if you are just getting started, but also if you are an experienced developer looking to refresh your skills or fill in a few knowledge gaps. I am in an empty folder in the Visual Studio Code. Let's initiate Node.js project with npm init-y. And as usual, the link to the code that you're going to see in this video will be in the description below. The next thing that we're going to do is to install and configure TypeScript. We are going to install TypeScript at types node and at tsconfig node24 as a dev dependencies. TypeScript and at types node is kind of self-explanatory, but at tsconfig node24 is actually tsconfig base that we're going to be extending. And tsconfig base is basically a base configuration of the TypeScript for Node 24. I currently have installed Node version 24, which is a long-term support, and you should use tsconfig base for the Node version that you are currently using. And the way to find out what other tsconfig bases are there, you just go to typescriptlang.org, click on the docs right here, choose TS for the new programmers, and here under project configuration on the left-hand side, you can just click what is a tsconfig.json. And then scrolling down a little bit, here you can find information about tsconfig bases. And if we click on the link right here, the GitHub link, we can see that there is a repository with a basis. You click on the basis, and then you can see all the bases that you can use in your TypeScript projects. Going back to our project, let's go ahead and create tsconfig.json file to define TypeScript configuration. In the first line of this configuration, we will extend tsconfig node24 tsconfig.json. In the compiler options, we put output directory as .dist, and the root directory will be src. This will be the source directory of our project where we're going to put all TypeScript files. Force consistent casing in file name, we'll set it to true. And then we put the include property, and in this property we'll specify to include the files, all the files and folders from the src directory. And that's it. That will complete our tsconfig JSON file. It's pretty short since we're extending Node24 tsconfig base. Now we can install Express with the command npm install express. And we will also install the types for Express as dev dependency. And now let's go ahead and create server.cs file in src folder of our project. In the server.cs file, we will import Express from Express. Then we're gonna create an app by calling Express. And we're gonna create our first route. We will call the method get on the app. And the first argument that this method will take is the route. In our case, it's a root route. And then there is another argument, which is a callback function, or it's also called route handler function. And it will take two arguments, rec and res. You call them whatever you want, but the convention is to actually call them rec and res. And then there's also a third argument that you can put in there. It's called next, but in most cases you are not going to use it. In this callback function, we're going to call send method on the res, and we just put hello world, and that's all we're going to do. Finally, we're going to call listen method on the app, and in this method, we're going to pass port 3000 as an argument, and again, another callback function. And in this callback function, we'll just simply console log Express is running on port 3000. And that's basically how you create an Express server. Now we'll need to run our code. So in order to do that, we'll go to package.json file, and in the scripts section right here, let's put the two scripts, and there will be build and the start script. So build script has a tsc command. It's basically TypeScript compile command. And then the start command will just have node, and we're going to run server.js file in the dist directory, since in the tsconfig file, we defined that our code will be compiling to the dist directory. So the start command will actually run the code from the dist directory. Let's save changes and then run the command npm run build. Our code compiled successfully. We got the dist directory created in our project. So now we can run npm run start. And we got the message that the Express is running on port 3000. If we go to localhost 3000 in our browser, we can see the message hello world. Let's go back to our code and make a change. Let's say we just want to say the word hello. We're gonna save the changes, and when we go back to the browser and if we refresh the page, we will still see hello world message. In order for the change to take effect, so we basically need to do Control-C and then do npm run build, and then also run npm run start. Now if we go to the browser and refresh it, we can see our change, so it just says the word hello. Obviously this workflow is really inefficient, and it would be nice to run build and start command when actually the code is updated. As you may have already guessed, there is a way to do that. However, it is not as simple as just combining these two commands, build and start. We'll have to use a package. There are different packages out there, but I prefer to use TSC Watch. Let's go ahead and install TSC Watch package in our project as a dev dependency. Now we can add a dev command to our scripts. We will just call TSC Watch, and on success, when the files are compiled, we're going to call node and then server.js file in the dist directory. Let's go ahead, save the changes, and now we can run npm run dev. Now we have a message that we got 0 errors, meaning our code compiled successfully, and we have message watching for file changes, and Express is running on port 3000. Now if we change our code in server.ts file, for example, we can change hello to hi and save the changes. You can see that the code got recompiled and the Express server got restarted. So if we go to the browser and then we click on the refresh, we're gonna see the new message. It says hi. And this is how you can create and run a simple Express server in TypeScript. But as you may have already guessed, Express is a little bit more powerful than just sending simple responses. So let's see what Express can also do. When sending responses in Express, you can also specify status. By default, Express sends a status OK 200, but you can override it with a status method. Let's put status 500. You can just go ahead and save the changes and go to the browser. So we can refresh the page, and now in a console, you're going to see that the response came with a 500 internal server error status code. You can put pretty much any status code you like. For example, you can put 404 not found response here. So we can just put 404 and then send the message not found. And again, if we switch to the browser, refresh the page, we're going to see the response came back with a 404 not found status code and message not found. Most of the time when working in Express, you will not be responding with like a plain text. You will be actually responding with a JSON, and it's easy to do in Express. You just use the JSON method. Right here, we can just put res.json and we pass it a JavaScript object, and Express will automatically convert it into a JSON response. So let's go ahead and switch to the browser. Refresh again, and then you will see the response is the JSON object, right? And if you have a Chrome plugin installed that reads the JSON, it's gonna show you JSON object. However, to see the raw response, you can click here on the view source, and you can see that the Express server responded with a JSON response. The next thing that you can do in Express is to make browser download files. So to do that, you can just use the download method on the response. And then as an argument to this download method, you just pass the file. So let's go ahead, save the changes. And now when we go and refresh the browser will open the window for us to download the file. So here you kind of don't see what's happening, but basically I have a window for the file download that opened. Besides making browser downloading the files, you can also make browser to render files. So basically displaying a web page. So all you have to do is to call method render, and then you're going to pass the view, like let's say index. However, in this case, it's not going to work because we need a view engine. There are different view engines out there, and most common are POG or EJS. Let's go ahead and use EJS. We can install it with npm install EJS. After you install EJS, you actually need to put the following line in your code, and it should be kind of word by word. So you're going to put
app.set view engine, and here's EJS. So the views usually live in the view folder, and by default this view folder will be in the root of our project, but you can actually specify a different location for your views. You have to just look at the EJS documentation. So let's create a views folder in the root of our project with a index.ejs file in it. And in the index.ejs file, we're going to put a simple HTML doc type file. It's basically an index HTML file, but since we're using the EJS engine, the extension is .ejs. Let's go ahead, save the changes, and run the server with npm run dev. And if we switch to the browser and refresh, we're going to see the message failed to look up view index in views directory. Let's go back to our Visual Studio Code, and it looks like I misspelled the folder views. So let's go ahead and fix it. We'll just do rename, and it looks like I swapped I and E. So let's go ahead and fix that. And now if we're going to go to the browser and if we're going to refresh it, we're going to see the page Hello World, and it says this is a simple HTML page. Express can also dynamically render pages. So as a second argument in the render method, you can put an object like, for example, text hello from EJS. So you have the key and the value for your variable, and then those variables you can render in your view in the index.ejs. Let's try doing that. In order to do that, you can just use templating, and what you do, you basically put less sign, then percent, then equals, and then you put your variable right here. Also, you may seem like, the syntax is not highlighted here. That means you have to install EJS plugin for your Visual Studio Code. Let's do just that. If you go to plugins and look for EJS, you can see EJS language support right here. You just click install. And then after EJS language support is installed, if you go to the index.js, your syntax will be highlighted right here. So basically all this syntax means, like I said before, you just need to render, run the code basically, right? Run JavaScript code. So it's going to render our text that we put in our server.js saying hello from EJS. Let's go to the browser and refresh it, and then we can see the text hello from EJS that got rendered dynamically. Also, you got to be careful when rendering the text. For example, if we put, for example, right here, text1, right, it's not going to match the text that we have in the index.ejs. Now, if we refresh the code, refresh our browser, right, so we got an error, and it's going to say reference error, and the text is not defined because we're defining actually text1. So in order to avoid this, you actually can use locals. So let's go ahead back to VS Code, and in our views.index.ejs, we can just put the word locals.text. So now you're accessing text on the locals object. So obviously if text is not there, it will be undefined and the page not gonna break. So let's go ahead and save the changes, go into the browser, and again, refresh the page. And all we see, hello from EJS, is not rendered there because it is undefined. When you were working with templates, right, EJS templates and rendering, always use local. So in case you make a mistake, you won't break your HTML page. When working with views and HTML in particular, you would want to basically, connect your CSS file or JavaScript file and also render images on the page. And you can also serve them using Express. For example, let's see if we want to show the image, for example, image JPEG right here, right? We need to serve it using Express. In order to serve static files in Express, you need to use the Express static middleware. I will explain what middleware is in the next section of this video, but for now you can just put Express static and then you put path, right? As an argument, you just put the path to the folder that will contain static resources. And in our case, this folder is called public and it will be in the root of our project. Here we also are using path join, right? So basically we need to import this so the error goes away. Now all we have to do is to create this public folder in the root of our project. And then we need to put image.jpg file because we're trying to show this image.jpg file on our index.ejs page. we just put this image.jpg file in the public folder, and this image will be displayed on the web page. So I did just that. Here's my image.jpg file. Let's go to the browser and refresh the web page. And now you can see that the image is showing below. This is a simple HTML page text. With the knowledge of how to render pages in Express.js and how to do it dynamically, and also how to serve the static files, you have all the tools to basically create a full stack server-side render application using Express.js. But I'm not going to go deep into this, because nowadays, if you want to do that, you have better tools like Next.js or React Router app. So you can use those full stack applications to create the websites. What is Express mostly used for is building APIs, and that's what we're going to dive into next. Express follows RESTful patterns. So for example, if you need to respond to the request that has HTTP method get, right, you put app.get. If you want to do respond to the post method, you just do app.post. So let's create a couple more route handlers, right? We'll do app.get. There's going to be tasks, right? And we're going to respond with an object that has an array of tasks, and then also app.post, and also the same route will be /tasks, and we just kind of respond with a created task right here. Let's go ahead and test these routes, but we can test app.get tasks in the browser. However, we cannot really make a post request in the browser without doing the coding. Usually to test API, you can use API clients such as Postman. However, VS Studio Code has a plugin actually that can help you test the REST APIs. So let's do just that. This plugin is called REST Client. So if you don't have installed it, please install this REST client right here. I already have it installed. So, and then all you have to do is to create a file with an extension .http. We're going to create API test.http file in the root of our project. And we're going to put the following code in there. So we're going to put 3 hashtags, list tasks, and we'll put the get request. So we have get http localhost 3000 /tasks. That's our tasks root or route. And now to test it, let's go run npm run dev. And now we can simply click right here on send request, and be sure you have these 3 hashtags there. That's what lets you have this send request. So click on that, and you can see that we got the response with the OK200, and we can see the list of our tasks. So now you can imagine if you have a lot of routes, right, in your server.js file, it's not going to be manageable. So what you normally would do, you're going to create a specific folder. It's called route, and that's where you can manage the routes. Let's go ahead and put our tasks in a tasks route. The convention is to create the routes folder. We can do it in src folder of our project. And in this routes folder, we can create tasks.cs file. And in this file, we can define our routes. So let's go ahead and go to server.ts file. We can go and copy these 2 routes, right? And then we can paste them in the tasks.cs file. So, however, it's not gonna really work, right? Because we have the app here, and what we can do, we can actually define a router instead. Let's go ahead and import Express from Express, and we also define and export the task router. And what we're going to do, we're going to just call the router method on the Express, and R is capital here, and which will give us basically an Express router. And the Express router works very much the same like an Express app. Now, instead of the app.get, what we're going to do, we're just going to use the task router. Also, we can remove the tasks here, so we will use the route handler tasks when we import the router in the server.cs file. And let's go ahead and do just that. Now in the server.cs file, we're going to go ahead and import the task router from routes and tasks. And just before app.listen, we're going to put app.use, and that's where we're going to be using the tasks, and we're going to use our task router. Let's go ahead and save the changes. Go to api.test.http file and send the request again, and everything is still working, so our refactoring went well. Besides listing all the tasks, we may want to get a specific task. For example, we want to get the task by ID of 2, right? And 2 is the route parameter, and this 2 is dynamic because we can do it by 1, by 2, by 3, etc., right? So in order to grab this dynamic part, what we can do is to use route parameters in Express. So in the routes.task.ts file, let's create another route handler, right? It's going to be the same taskRouter.get, but here we have a dynamic parameter, and we put colon ID, right? And then to get this task ID, we're going to call rec.params, and since the parameter is called ID, we call this ID. So, and then when responding with a JSON, right, we put this ID as the task ID that we got from the route parameter, and also use it in the title task ID. Now, when we go to API test.htp file, we can see that this says task1, right? Now, if we change it to 2, for example, and send the request, it's going to say task2. So, and that's how you can get dynamic route parameters in Express. Besides handling dynamic route parameters, we should be able to handle the body, right? Because when we create a task, for example, right, we're going to be sending the body, right, with the title of the text and, for example, completed, true or false, and we do it with a post request, and we also specify the content type. In our case is application JSON, and it's actually very important when you make the post request, and we will see why in a minute. So in a task.cs file, let's go ahead and update the task router post route handler. So the way we can get the body from the request, right, we can just get rec.body, and then we can get the properties from the body. For example, title, we can do rec.body.title, or completed, we can do rec.body.completed. So, and then we can just respond with a JSON, task. We'll put the title that is title and completed as completed, and obviously we can just simplify it to do just this. So in a tasks.cs file, let's go ahead and update the code for the task route handler. So we use the task router post, and we're gonna get the body, right, of the request from the rec.body. So, and then from that body, we can get the properties. For example, title, we'll do rec.body.title, completed rec.body.completed, and we will respond with a JSON, right, the same title and completed that was sent to us. So let's go ahead, save the changes, and we're going to go create and send the request. However, as you can see, it's actually did not work because it's going to say cannot read properties of undefined. So it means that body is actually undefined. In HTTP, right, when you're sending the requests, the body is really a stream, right? So Express needs to know how to process this body and where to put it. Since our content type of the post request is application.json and we're sending the JSON, we can tell Express to parse this body as a JSON. So in the server.ts file, we're going to add another middleware. This middleware will be express.json. We'll use, again, app.use method on it, no pun intended. And like I said, I'll explain what middleware is in the next section. So now when we make changes and save them, and then go to the API test.htp file, make a request, and then we got a response, and the title of the task is another task that we sent in our request, and completed is false, again, the same thing that we sent in our request. So now you can see that the content type header is actually pretty important here, right? So if we remove it and then we make a request again, we will have the same error, because now Express doesn't know what to parse this JSON request body, because we did not specify the header. And then if we put the header back, right, and make the request again, we can see that this code works. Another common format that the body is sent in when making post request is actually a form data. So let's have another route, create a new task with a form data. Obviously, if we send the request right now, we again have a problem because we cannot read properties of undefined, and this is because there is no form data parser, body parser middleware. So what we can do, again, we can go into server.cs file and use another middleware to parse the form data. And this middleware is called express.url encoded, and usually you would put extended true, right? And extended true allows you to parse the reach objects and arrays. In our case, it doesn't really matter because we have just a simple title equals another task and completed false, right? Simple kind of body. But if you have like arrays and stuff, you want to put extended true. And if you don't put anything in here, there will be extended false. That's the default value in Express. Back in the days, you actually had to specifically put it, but now you really don't have to, right? Express will default it to false. So now if we go to API test.http file and click on a send request to create a new task with the form data, again, the request works. Besides accessing the route parameters and parsing the body in Express, you would want to also access the query parameters. For example, if somebody is searching for tasks, right, we can have question mark, right, query parameter, search equals to title, right? And in this title, you can put whatever you want, for example, like my title. And obviously, if you have a space, it should be URL encoded, but the REST API plugin will do it for us automatically. So to be able to access query parameters, right, in a task.cs file, we can update our get route handler to do just that, right? And the way you access the query parameters, you do reg.query, and our parameter is called search, right? Call it as a string or undefined. And now, if we have this search, right, we're gonna return the response, right? And we'll put the title of the task search. So we're faking it as if we found this article, right? And if this parameter is not in the query, so we'll just return the list of tasks. Let's go ahead, save changes, and test our code. So if we click send request with the search tasks, right, we can get the task that it says my title, because now we have a search query parameter my title. So besides get and post request, right, Express can also handle put or patch, right, and delete as well. And all you do, you just put the method put right here and delete. In our case, we're basically getting the ID, because when you're updating the task, and that's what put method is for, to update your resource. So you use the ID, you get it from the route parameter, and then you update it. The delete method works the same. You grab the ID from the route parameter, and then you find your task by ID, and you essentially delete this task. And this is how you define routes in Express. And essentially what we did here, we just created a RESTful API. I mean, obviously it's a little fake, right? Because we don't have real data, but nonetheless, it is a working REST API. Let's talk about middleware. Middleware is really a great feature of Express. Middleware is a function that is called before one route or several routes. Depending on where you put it, this function is executed before a single route or several routes. We already know that Express has built-in middleware, for example, Express.json, Express URL encoded to parse the body, or Express static to serve the static file. And since we put these middlewares above all our route handlers, they will be executed before all the routes. Let's go ahead and create our own middleware. We will define a function logger because it is useful to log the requests, and this function will take three parameters: rec, res, and next. So basically the rec and the res parameters we know already, right? We use them in the request handler, and then the next is the function that will be called when the middleware executed, so execution is passed to the next route handler. If you forget to put the next function, your application sort of gets stuck, and then the request is not passed to the next route handler. So in this logger middleware, we will console log reg.method and reg.path. So .method and .path are also useful properties where you can get the method of the request and the path of your request. And then we simply put a new date in ISO string. In order to use this middleware logger function, we can simply do app.use, and we can just put logger. We don't put the parentheses after this, calling this function, because Express will be smart enough to actually call it. So you don't put parentheses like so. You only put this if this middleware is a higher order function, because sometimes you will need to pass additional parameters besides the rec, res, and next. Then you wrap your logger in another function, right? And then you pass the parameters and return your logger function or whatever middleware you are doing. Let's go ahead, save the changes, and run the application. Now if we go to api.http file and send the request, you can see that our middleware is logging that it is a GET request and goes to the tasks route and today's date as well. Normally, you don't put your middleware in a server.cs file like I did, right? You usually create a folder for it, and the convention is to create middleware folder. So let's put the middleware folder in the src folder. Now in this folder, we can create logger.cs file. And we can go ahead and cut out the function logger from the server.cs file, and we can put it in the logger.ts file, and we won't forget to export it. And then we will also need to import Express from Express. All right, now we need to save changes, and we will need to import the logger right here. So this error goes away. All right, and now if we make another request, let's say we want to create a new task, we'll do a post request, and our middleware still works. You can see method post going to the route tasks. Another middleware that you're going to be using when building APIs is auth middleware to authenticate the requests. Let's go ahead and create auth.cs file in the middleware folder. As usual, import Express from Express, and then we export function called auth, and we'll pass rec, res, and next. And then in this function, we will try to get the API key from the rec.headers, and the header will be X API key, and rec.headers is the way you can get the headers from the request. So then we will check if API key equals to mySecretKey. Obviously, you're going to put this mySecretKey in the environment variable, but for simplicity, I'm just hard coding it. And then if it is equal to mySecretKey, so it checks out, we call the function next. However, if it's not, we're going to be responding with a status 401 and JSON response with a message unauthorized. So this is the usual message that you send when request is not authenticated, and the status code will be 401. Now let's go into routes tasks.cs file. We can import this middleware. And now what we can do is attach it to the task post route. So in order to create a post, user needs to be authenticated. And what we can do here is to put it as another argument into the post function, right? So you have the route here, then you have auth, middleware, and then you have your route handler. Let's go ahead, save changes, and try it. Now, if we list tasks, right, we can see the tasks. So this route is not protected. However, if we go and try to create a task, this route is protected, and we receive the message unauthorized. In order to get authorized to create a task, all we have to do is to add the header X API key, mySecretKey, to our create task request. So now if we send this request, our user is authorized and the task is created. You can also attach your middleware to several routes, not just one route. So let's say we want to protect our mutable routes, right, which will be post, put, and delete routes. So all we have to do is actually to put middleware just above those routes. So we can do it with a task router.use, and then we can just put auth middleware right here. So now not only create a new task route is protected, but update task is also protected as well. So if we create a request to update a task, we can see the message is unauthorized because we don't have the API key header. Besides Express built-in middleware and middleware that you can create, there are a lot of packages with a useful middleware. Let's go ahead and install a couple of them. We will go ahead and install npm install Course and Morgan. So Course is a useful middleware when you're building APIs. It can be used to enable cross-origin resource sharing with various options, and Morgan is the middleware to handle the requests. And we will also need to install types for both Course and Morgan as a dev dependencies. Let's do that. Now in a server.ts file, we can import both Course and Morgan and use them like so. So we can do app use Course, and this is a function, so we need to call it. It will return the middleware function. And the same thing with Morgan, we can do app.use Morgan. This is also a function, and here we need to pass what kind of format for the logs we want to use. I usually use tiny. Now, since we have Morgan middleware that logs our request, we actually don't need the logger middleware, and we can just simply remove it. Let's go ahead and do that. So now if we go to api.test.http file, we can't really test the Course middleware. However, we can test the Morgan middleware, the logging of the requests. So we can send the request to list our tasks. And as you can see, the Morgan logged out the request method, the route, the status of the response, which is 200, and how long it took to respond. It is 3.363 milliseconds. Pretty useful information about the requests. Besides running the middleware when things go well, you can also run a middleware when things don't go so well. Let's go to the tasks.cs file. Here we have routes, and we have the route that gets the task by ID. Let's go ahead and throw an error here. I'm going to put throw new error, and we're going to put message something went wrong. All right, now if we go to API test.http file and make the request to get task by ID, we will see that we have an error response right here. And this error response is not looking pretty, right? We have the HTML actually responding with a something went wrong error and the whole stack. Also, this error is logged out, in a console. This is very useful for developers. However, the response that is returned to the user is not very useful to the user. First of all, it's kind of a lot of stuff here. Second of all, it gives out a lot of information about the application. Also, the reason our application didn't crash is actually request has error handler, right? It intercepted the error and then it logged out, and our application didn't crash, so we can just continue as normal, maybe making like at least all tasks request. The Express error handling middleware runs after all the route handlers, right, at the end, but we don't really see it because it's hidden. However, we can also create our own error handler middleware, so we can return the response to the user the way we want or handle errors the way we want. So let's go ahead and do just that. In the middleware folder, in the src folder, we are going to create a file called errorhandler.cs. In the errorhandler.cs file, we're going to put the following code. We're going to be importing request response and the next function from the Express. This time we'll just destruct it, not to drag the Express. So then we're going to create export default function error handler, and we will pass error, unknown, rec, res, and next. So rec, res, and next, we know already about them, but if you are doing the error handler middleware, you need to pass the error as the first argument to this function, or the first parameter to this function, and also error will be of type unknown. This is how TypeScript treats errors. It's not like any or an object, it's really unknown because you can throw anything as an error in a JavaScript. Next, we're going to check if the response is already sent with a res.headers sent. And if the response is already sent to the user, we can't really send another response. So in this case, we will call the function next and pass it an error. So it ultimately will pass this error to the Express's built-in error handler, and it will just log it for us the way we saw it before. And then we simply return. However, if the response is not sent, right, we can actually create our own response with a status 500 in JSON, and we can put error and put an error message, right? Error.message or internal server error. And basically that's it. So we handling our response specifically, to cater to the user, not to expose too much information. And then after that, I also like to call next error. So now Express built-in middleware will actually log the error and the error stack for me, because I think Express does a pretty good job logging the error. Now, if we save our code, you can see we have a TypeScript error, because error in the TypeScript is a type unknown, so it's not an object. We cannot just simply call message. In order to safely get message from the error, what we need to do is to create a helper function get error message. So let's go ahead and in the src folder, let's create another file called utils.ts. In this file, we're going to put the following code. This is basically a utility function, get error message. It will first check if the error is an instance of error. Then it's going to return error.message, because we can access message property on the error object safely. Then it's going to check if the error of type of object and there is a actually message property on this object. If so, it will cast it to string and return the error message. And then if type of error is string, we can just return that error. And finally, if none of them applies, we just return a generic message and error occurred. Now what we can do is simply go to our error handler middleware, import this get error message, and then we can just simply call our message will be get error message, and we will pass error to it. Finally, after you create the error handler middleware, you need to use it in the server.cs file. First, we're going to go ahead and import it. And then we need to put it at the very bottom, right before the app listen or after all our out handlers, right? So we're going to put app.use, and we can put error handler. Now let's go ahead and test our code. We'll go to api.test.http file. We'll try to get test by ID. Again, we can see that the Express logged out the error stack for us. However, the user didn't receive all this mumbo jumbo. He just received a message that something went wrong. So error handler middleware is very useful for handling, well, mostly unhandled errors in your Express application and then returning some kind of, sensible message to the user. And to make a final point about the error handler, right, if you look at the logs right here in the console, you can see that the error happened actually in routes.task.js file rather than TS file, because obviously we're compiling TypeScript file into JavaScript. However, this may be a little bit hard to find, if your application is rather big, right, you'll have all these JS files and you need to map them back into the TS files. In order to see the errors in the TS files rather than JS files, we can actually enable source maps in the TypeScript, so the TypeScript will map it for us automatically. In the tsconfig.json file, we need to add another property to the compiler option, and this property is called source map, and it's going to be value true. Alright, besides that, we actually need to install a package to see the source maps. Let's do that. This package is called source map support. So we'll do npm install source map support. Now all we need to do in server.cs file, we're going to go ahead and import this source map support. And what we need to do is import source map support /register. Now we can save the changes and start the application. And if we go to API test.http file, send request to get task by ID, now you can see that the error stack contains the tasks.cs file. It's a line 22. Now we can go to that tasks.cs file, and on line 22 we can see the error that is thrown, and we can actually remove it now. And here you go. We just built a complete Express server with a TypeScript, dynamic template rendering, REST API, middleware, and custom error handling. If you enjoyed this video and would like to dive deeper into how to build powerful REST APIs, please check out my complete course, Node.js REST API Mastery, Build Powerful APIs with Express.